Storage devices. Storage devices are used to save and retrieve digital data on a computer. They differ in their capacity to store data, that is, their storage capacity. Let's understand the units of storage capacity. Bits and bytes are the units of storage for data. The smallest storage unit is a bit, which is a binary digit that can either be 0 or 1. A byte represents a character and consists of 8 bits, letters, numbers and symbols. A byte is made of 8 bits and a kilobyte KB is made of 1024 bytes. 1 megabyte MB is equal to 1024 kilobytes. 1 gigabyte is equal to 1024 megabytes. 1 terabyte is equal to 1024 gigabytes. In other words, the more bytes there are, the more files may be saved in a given quantity of space. Here are some examples of storage devices with their storage capacities. Hard disk drive, HDD. An HDD is like a big spinning file cabinet inside your computer. It can store a lot of data like the operating system, software programs, and files such as photos, videos, and documents. HDDs typically come in various capacities ranging from a few hundred gigabytes to multiple terabytes. For example, you can find HDDs with capacities like 500 GB, 1 TB, 2 TB, or even larger. Solid state drive, SSD. An SSD is like a super-fast USB stick inside your computer. It uses special memory chips to store data quickly and is more reliable than HDD. It helps your computer start up faster and makes programs run smoothly. SSDs also offer a wide range of storage capacities. Common capacities for consumer SSDs start from around 128 GB and go up to several terabytes. Examples include 256 GB, 512 GB, 1 terabyte, or 2 terabyte SSDs. USB flash drive. A USB flash drive is like a small, portable storage device that you can carry in your pocket. It plugs into a USB port on your computer and lets you save and transfer files. It's handy for sharing files or keeping backups. USB flash drives come in smaller capacities suitable for portable storage. They typically range from a few gigabytes to several hundred gigabytes. Examples include 16 GB, 32 GB, 64 GB, or 128 GB USB flash drives. Some high-capacity models can go up to 1 TB or more. CD, DVD, Blu-ray disc. These are like shiny discs you can put in your computer's CD or DVD drive. They can store movies, music, software, and other files. You can watch movies, listen to music, or install programs from them. The storage capacity of optical discs varies depending on the type. A standard CD can store around 700 MB of data, while a DVD can hold approximately 4.7 GB to 9 GB dual layer. Blu-ray discs offer even higher capacities ranging from 25 GB single layer to 50 GB dual layer. Memory card. A memory card is a small storage device that goes into camera, phones, or tablets. It stores photos, videos, and other files. It's like a little chip that holds your memories and can be easily taken out and put in other devices. Memory cards for cameras, smartphones, and other devices come in a range of capacities. They typically start from a few gigabytes and go up to several hundred gigabytes. Examples include 32 GB, 64 GB, 128 GB, or 256 GB memory cards. Higher-end cards can even reach 1 TB or more in capacity. Network Attached Storage, NAS. NAS is like a special storage device connected to your home or office network. It allows multiple devices to store and access files from a centralized location. It's like having a shared storage space for everyone to use. These storage devices come in different shapes and sizes, but they all serve the purpose of saving and retrieving data in different ways. They are important for keeping your files safe and accessible whenever you need them. Ports and connections. A computer system has various ports and connections that allow for communication and interaction with different devices. Here are some common ports and connections found on a computer system. USB, Universal Serial Bus, ports. USB ports are widely used for connecting peripherals such as keyboards, mice, printers, external hard drives, and USB flash drives. They allow for easy plug-and-play functionality and data transfer. HDMI, High Definition Multimedia Interface port. HDMI ports are used to connect displays such as monitors, TVs, or projectors. They transmit high-definition audio and video signals, providing a digital connection for clear and crisp visuals. DisplayPort. DisplayPort is another type of video connection commonly found on computers and monitors. It supports high-resolution displays and can transmit audio and video signals. Ethernet port. The Ethernet port is used to connect a computer to a local network or the Internet using an Ethernet cable. It provides a reliable and high-speed wired connection. Audio ports. Audio ports are used for connecting speakers, headphones, or microphones. The most common audio ports are the 3.5 mm audio jack and the larger 6.3 mm audio jack. Some computers may also have digital audio ports such as SPDIF or optical audio. VGA, Video Graphics Array port. VGA ports were popular in older computers and monitors but are now being phased out. They transmit analog video signals and are used to connect older displays or projectors. DVI, Digital Visual Interface port. DVI ports are used for connecting displays similar to HDMI and DisplayPort. They support both analog and digital signals but do not transmit audio. Thunderbolt port. Thunderbolt ports are found on some computers, especially Macs. They provide high-speed data transfer, video output, and power delivery in a single connection. Thunderbolt ports are backward compatible with many DisplayPort devices. SD card slot. SD card slots are commonly found on laptops and some desktop computers.
They allow for easy insertion of SD memory cards used in camera,
smartphones, or other devices. These are just a few examples of ports and connections found on a computer system. The specific ports available can vary depending on the computer model and its intended use. Operating system and its types. We have already learned that the operating system is the most important software on a computer or mobile device. This is the software that starts working as soon as we switch on a computer. It displays the desktop on the monitor. Some of the most commonly used operating systems for laptops and desktops are Ubuntu, Microsoft Windows, and Mac OS. Mobile devices also have an operating system that helps them perform their functions. Some of the mobile operating systems are Apple iOS and Google Android. All the computer applications such as browsers, games, office tools, etc. are also software programs that perform a particular function. Processes for starting and shutting down a computer. When a computer is switched on, it goes through a few basic operations or processes before it is ready to accept commands from the user. To start a computer, follow these basic steps. Step 1. Ensure that the computer is properly connected to a power source. Plug the power cord into the computer and connect it to a functioning power outlet. Step 2. Press the power button located on the computer case or front panel. The power button is typically marked with the universal power symbol, a circle with a line. Step 3. The computer will begin to boot up and you should see the manufacturer's logo or a black screen with text. Step 4. The operating system such as Windows, Mac OS or Linux will start loading. This process may take a few moments. Step 5. Once the operating system is fully loaded, you will be presented with the login screen. Enter your username and password to access your computer. Step 6. After successfully logging in, you will be taken to the desktop or home screen of your operating system where you can start using your computer and launch applications. Remember, the exact steps may vary depending on the computer and operating system you are using. If you encounter any issues, consult the computer's user manual or seek assistance from a knowledgeable person. Starting a computer with Windows 10. To start a computer running Windows 10, follow these steps. Step 1. Ensure that the computer is connected to a power source and turn on. Step 2. Wait for the computer's hardware components to complete the power on self-test, post, and initialization process. This usually takes a few seconds. Step 3. Once the initial hardware checks are completed, the Windows 10 operating system will begin to load. You will see the Windows logo on the screen. Step 4. After a brief moment, you will be presented with the login screen. If your computer has multiple user accounts, click on the account you want to log into. If you have only one account or have set up automatic login, you will bypass this screen. Step 5. Enter the password for the selected account if required and press enter or click on the arrow button to proceed. Step 6. Windows 10 will now load the desktop and other system components. This may take a moment depending on your computer's speed and the number of startup programs. Step 7. Once the desktop is fully loaded, you will see the Windows taskbar at the bottom of the screen and various icons and shortcuts on the desktop. Step 8. You can now begin using your computer in Windows 10. You can open applications, access files, browse the internet, and perform other tasks as needed. Remember, the startup process in Windows 10 may vary slightly depending on your computer's configuration and any customized settings you may have. Basic operations when a computer starts. When a computer starts, several essential functions are performed to ensure the proper initialization and operation of the system. Here are the basic functions that typically occur during the startup process. Power on self-test, post. The computer's hardware components such as the CPU, memory, storage devices, and peripherals undergo a self-test to check for proper functioning. Post verifies that all essential hardware components are present and operational. BIOS UEFI initialization. The basic input-output system or Unified Extensible Firmware Interface UEFI firmware stored in a chip on a motherboard is loaded. It initializes and provides low-level control for hardware devices including the CPU, memory, storage, and input-output interfaces. Boot sequence. The system identifies the storage device, typically the hard drive or SSD, where the operating system is located. It reads the boot sector or boot loader code from that device to initiate the loading of the operating system. Operating system loading. The selected operating system, such as Windows, Mac OS or Linux, is loaded into the computer's memory from the storage device. The operating system initializes drivers, services, and other system components necessary for proper functioning. Graphical user interface initialization. Once the operating system has loaded, the graphical user interface is initialized, presenting the desktop or login screen. The GUI provides the visual environment where users interact with the computer using windows, icons, menus, and pointers. User login. If user accounts are configured, the login screen appears, prompting users to enter their username and password. Successful authentication grants access to the user's personalized desktop and settings. Login and logout. When sharing a computer with other people, each user has his or her own files and application. To ensure that nobody else can access your work, you have login IDs, that is usernames and passwords. You can use the computer by entering the username and password, which act as keys to the lock. When you log into the computer with your login ID and password, screenshot, the computer knows that you are an authorized person and allows you to work on the applications on the computer. Once you finish working, you must log out or sign out so that no one else can see your work. Background processes. After login, various background processes and services continue to initialize and run silently. These processes handle tasks such as system monitoring, network connectivity, security features, and software updates. User interaction. With the computer successfully started and the operating system running, users can now interact with applications, access files, browse the internet, or perform other tasks based on their needs and preferences. These functions collectively enable the computer to go from a powered-off state to a fully operational state, ready for user interaction and the execution of desired tasks. Shutting down a computer. To properly shut down a computer, follow these steps. Step 1. Save and close any open files or applications you are working on. It's important to save your work to avoid losing any unsaved changes. Step 2. Click on the Start button located in the bottom left corner of the screen. Step 3. In the Start menu, click on the Power button. This will open a submenu with various options. Step 4. From the submenu, select Shutdown. This will initiate the shutdown process for your computer. Step 5. Wait for the computer to complete the shutdown process. You may see a screen indicating that Windows is shutting down and your computer's screen may turn off or display a no signal message. Step 6. Once the shutdown process is complete, the computer will be powered off. It is now safe to turn off the power source, such as by unplugging the power cord or pressing the power button on the computer if applicable. It's important to allow the computer to fully shut down before turning off the power source. This ensures that all processes are properly terminated and that the system is not interrupted during critical operations. Improperly cutting off power to a computer, such as by abruptly unplugging it, can cause data loss or other issues.